Hi everyone, and welcome to another video that we're going over a past assessment because we have the retake version now available. So since I have retake versions all posted online, the old versions are no longer available. You can't do those again because I'm going over the answers as we speak, right? I'm giving you the answers to the test. So on this, I'm going to be going over the answers. I'm not going to go over in detail all the past concepts that we're applying or using, okay? I will talk about how we're applying them, how they make sense, how we justify our answers to these kinds of problems, right? What we're using to do it, but I can't go over like what is the Hinge theorem again, right? Because I spent like 10 minutes on that the first time. So in lieu of that, if I'm talking about I'm going to use the Hinge theorem here, and you're like, what is the Hinge theorem? I don't even know where to start. Then this is not the video where you should start. I would recommend going back to the video on Hinge theorem, watching that, and seeing if that makes sense to you. And then if you're like, okay, well, I get the Hinge theorem, but I don't understand how to use it for this kind of problem, that's when you're watching this video, right? That's what this one's about, okay? So let's go over the Hinge theorem. And then the second part of this is going to be the isosceles theorem, using the isosceles theorem to solve those, okay? So the first thing here is we need to fill in these problems with the correct inequality. We have one of three options: greater than, less than, or equal to, okay? And we're going to use the Hinge theorem to do it. So again, hopefully you're well-to-do with the Hinge theorem. You got that in your notebook. You know how to apply it, right? And you'll see these are relatively not easy, but straightforward. They're almost a one-step process once you got it down, right? For example, here, I need to find measurement of angle 1 to angle 2. So I'm going to check, do I meet the conditions of the Hinge theorem? Well, I got a congruent side here and a congruent side here. And then they have a shared side in the middle. And shared sides of triangles, if you remember, are congruent to themselves, right? So this is a pair of congruent sides with an angle between them that we are comparing, right? So that is meeting the conditions of the Hinge theorem. So with those conditions met, now the comparison is like this. Opposite of angle 1 is the side length of 10. Opposite of angle 2 is the side CD, which has a length of 7. 10 is greater than 7, which means the measurement of angle 1 is wider than the measurement of angle 2. Like that. That's it, right? Once you know you've met the conditions of the Hinge theorem, all you got to do is compare the angle or side opposite of what you're being given, and then by comparing what's opposite to it, you find what it is. So here, HJ to PK. So I'm comparing the sides, HJ to BK. So since I'm comparing sides, I need to look at angles, okay? I'm given two congruent side pairs with an angle between to use. So that meets the conditions of the Hinge theorem, right? This is 90 degrees. This is 85 degrees. 90 is bigger than 85, which means the opposite side, HJ, is bigger than the opposite side, PK. A lot of people mess this up, and I'm honestly not super sure how. Because most people don't show their work for this, right? It's kind of hard to show your work. So I'm not sure how you messed it up. But remember, maybe you got the sign backwards, right? Maybe you misremembered the Hinge theorem. Maybe you were guessing. That's okay. Always guess on test. If you don't got it, guessing is fine. But here, this is 90 degrees, right? And 90 is bigger than 85, which means the opposite side is also bigger. Again, I'll review the videos if you need more explanation on the Hinge theorem. Lastly, I am comparing the side length KP to kg. So I'm going to highlight this on here to make it easier for me. Kp to kg. So I need to find what angle is opposite of those. Well, 70 is opposite this one, and 87 is opposite this one, right? That's helpful. I got a congruent side pair given to me, and then another congruent side pair given to me with measurements. So I do meet the conditions of the isosceles, or of the Hinge theorem, right? So I'm allowed to use that. What's bigger, 70 or 87? Well, it's 87, right? So Kp is bigger than Kg. And look at that. Every single one of them was bigger. The first one was bigger than the second one. So it actually was a pretty repetitive answer. Maybe you second guessed yourself, and that's why you might have got one wrong or something. I don't know. But that's applying the Hinge theorem. Again, it goes pretty quick once you got it down, right? It's pretty quick. It's not necessarily easy because there's all the work to get it down, to understand it to the extent that you can just apply it immediately. But once you do understand it to that extent, it goes pretty fast. All right. Next up, the isosceles theorem. So again, the isosceles theorem, I'm not going to be able to go over that in detail, but for a brief review, if I have an isosceles triangle, which is a triangle with two equal side lengths, then their opposite angles are also congruent, right? So these are two congruent sides, so their opposite angles are also congruent. Those angles being called the base angles, right? And vice versa, the converse of the isosceles theorem is if I have two congruent angles, then their opposite sides are also congruent, okay? So all isosceles triangles have two congruent sides and two congruent base angles opposite of the congruent sides. So here, I'm going to use this to my advantage. I know that I need to find x. I'm given 90 degrees here, but unfortunately, 90 degrees is not what's opposite of x. If you said x is 90, that just doesn't make sense, right? Because you have three angles in the triangle, but 90 plus 90 is already 180, and you need to add 280. So your third angle is a 0? That doesn't make sense, right? So what is going on here? Well, I've got 90 plus x plus another x, right? Because they're congruent to each other. And that all has to add up to be 180. The triangle sum theorem is going to come up a lot, so make sure you're familiar with it. This is the triangle sum theorem, right? Now that means 90 plus 2x equals 180. Okay, so I'm going to take away 90 from both sides because I need to figure out what's left, right? If this is 90 and these two are the same and this adds up to 180, what does x need to be so that it's going to be 90 plus x to equal 180, right? That leaves me with 90 left over to figure out. So 90 equals 2x, right? And that's going to be, well, if 2x is 90, then 1x is 45. Because I divided both sides by 2, right? So x is 45 because this is a 45, 45, 90 triangle. Okay. Next step. For 5, what are we doing here? Well, for 5, this one's actually more straightforward, I think. Opposite sides are also congruent, so x equals 13. Right? That was really fast, right? Not easy, but fast. If I know that the converse of the isosceles theorem is that base angles mean opposite sides are congruent, there you go. Next up, once again, two congruent sides, so opposite angles are congruent, right? 50 degrees, this is also 50 degrees. What is x going to be? Well, remember the triangle sum theorem that we were just doing, right? X plus 50 equals 180. So x plus 100 equals 180. So take away 100 from 180, and what do you have? 80, right? It's in the name. So x equals 80. So those are what I would call the more straightforward isosceles theorem problems. The only things you're using in these are the isosceles theorem and the triangle sum theorem sometimes, right? We're about to get a little trick here with the last two. So let's zoom in on this so you can really see it, right? What's going on here? Well, I need to find the value of x, okay? So to do that, I've got two triangles now touching each other that are both isosceles in different ways. So this is going to get a little trickier. Now, when I'm doing a problem like this, I don't need to know where I'm going in order to start solving it, right? If I just fill in enough pieces of information, eventually I will find x, okay? Or I can be strategic and start with x and figure out what I need to know to find x. I'm going to do it the strategic way. But again, if you're stuck on a problem like this, you can just bumble around and fill in things until you get the answer, okay? And I think we'll do that on the next one. So for this one, I want to find x. Well, I don't know x. So what do I know? Well, I don't even know any other angles in x. But what do I know about those angles? Well, those angles are opposite of two congruent sides. By the isosceles theorem, then, they're also congruent, right? These angles are congruent as well. So I know this angle is congruent to the other angle in the base angles, right? Now, I also know that this angle on the top here is a vertical angle congruent to this angle, right? So again, I'm just looking at what do I know about these things to be able to find x. Because if I can figure out what these two angles are, I can find x using the triangle sum theorem, right? Now, I know that, okay, these angles are all congruent. Then what is this angle going to be? Well, by the triangle sum theorem, it's whatever's left after the other two angles. So what do I know about the other two angles? Well, by the isosceles theorem, opposite angles of two congruent sides are also congruent. So this is also 65 over here. So now, after I've gone strategically backwards, running up the river to figure out what I need to get, I'm going to make it all flow right back down to give me the answer to x, okay? So these are 65. What is left here? Well, that's going to be 65 plus our question mark, right, equals 180, the triangle sum theorem. So I've got 180 minus 130, that's what 65 plus 65 equals, right? And I get 50 equals this angle, right? Now, if that's 50 by vertical angles, this is also 50. And if that's 50 by the isosceles theorem, this is 50. And remember, because this was using the triangle sum theorem, that's why we started finding those two other angles, right? I now know that x needs to be 180 minus 50 minus 50, right? That's going to be x equals 180 minus 100, and we just did that. What's 180 minus 100? That's 80, right? So x equals 80. There you have it. Notice another pattern here again, right? If the x is between our two congruent sides, it's not the thing being doubled, right? It's the 50s that got doubled. The angle that's between two congruent sides, that's like the top angle or the apex angle or whatever you want to call it, that's not the one that is being doubled with congruence, right? A lot of people mess that up. They just assume that x is the thing that's being doubled. Okay, so this time I'm going to pretend I don't know how to solve this one, right? I'm not going to do any strategic way. I'm just going to bumble around and fill in stuff, okay? So what do I know? I'm just going to put in everything I know here. Well, this is 90 degrees, right? And this bottom angle here is 28 degrees. So 90 minus 28 is whatever's left up here, right? And that's going to be, well, 90 minus 20 is 70. 70 minus 8 is 62, right? 62 degrees. So this is 62 degrees right here. I'll erase that to be a little clearer, right? This is 62 degrees because, again, this whole thing is 90 degrees, right? So I need to find whatever's left over. Okay, well, again, I'm not trying to get to x in any particular fashion. I'm just filling what I know. If I know this is 62 degrees, then by Isosceles theorem, right, opposite angles of two congruent sides are also congruent. That makes this 62 degrees. Okay, well, if I know that's 62 degrees, then I know these all add up to be 180. So 180 equals x plus 62 plus 62. That's going to be x plus 124. So I take away the 124 from both sides to leave x by itself, so I can figure out whatever x has to be, right, to make it 124. 180 minus 120 is 60, minus 4 is 56. Nice. So what are a couple of things I noticed here is a lot of people would give me an answer like 50 or 45. I know that's not going to be the answer. How do I know that's not going to be the answer? Because this is a 28. It's not an even, nice round number like that, right? Which means whatever's going to be over here is also not an even, nice round number. 5s take away from 10s, whatever, leaves you with 5s, right? 10s take away from 10s, whatever, leaves you with 10s, you know? So here, I know it's not going to be a 5 or a 10 at the end because this is some weird other number like 2 or 4 or whatever, right? In this case, it was a 6 that we got left with. So I know that if your number is too neat and tidy, it's not going to be the correct answer here. I didn't even have to check your work to see you got it wrong. And that's a great way to double check your work too. If my answer ended up being 50, I would be a little suspicious and try to make sure that I really did that correctly, right? Okay, that's it. That's the entirety of the Hinge Theorem and Isosceles Theorem quiz. We just did all the problems together. I hope that makes a little more sense looking over it and seeing what we did, right? And hopefully seeing that, again, it's not easy, but it's straightforward applying the Hinge Theorem, right? Once you know the conditions have been met, it's just a check, right? With a lot of Isosceles Theorem problems, it's also relatively straightforward. Not easy, but it's going to be a 1 or 2 step process. And then even when we get tougher on the Isosceles Theorem, when we throw in other stuff like vertical angles or complementary angles, right? Then there's still ways we can figure that out even without knowing where we're going. We can just fill in what we do know and eventually get there, right? Now, you won't need to worry about complementary angles so much on the test. I think the retake version does not have that, but it's still very useful to know, and it also is useful for some of the assignments we did. But every other one of these will be very useful to have reviewed for the retake, okay? Again, if I'm going over Isosceles Theorem, you have no idea what I'm talking about watching this video, that would be a great chance to go back and watch the Isosceles Theorem videos and check out what we did there and make sure you understand it. Likewise, if I'm going over Hinge Theorem you don't know or anything like that, check out those videos. If the videos aren't making sense and if this video doesn't make sense, email me. I'm happy to help out via email all the time, okay? So just email me and let me know what's up and I will get back to you and we can sort it out, okay? I hope this video helped out. I hope it makes a little more sense seeing me walk through the questions just like you can, okay? And I hope you have a great day. Thank you.